Hi everybody and welcome. Today we're going to be looking at an extension of 8.4. So doing pretty similar concepts but taking it to the next level. So something to review more explicitly today is rationalizing denominators. And what this means is we are basically simplifying a fraction in a way that removes radicals from the denominator. The reason that we do this is, one, it's poor form, but two, it's going to be harder to simplify things if we have those on the denominator. So we have to make sure all square roots, our radicals, are out of the bottom, because it's not something that we'll see on a standard answer choice question, and it's also something that is just going to make life harder down the road. So two reasons to do it, and again, we are making sure that we are using proper math etiquette, and that's one of the most common things that we need to make sure we do. So where this comes into play is, say for instance, you have something like 7 over the square root of 4. Well, in this case, again, if we look at the denominator, or the bottom, there is a square root, or a radical. We can't have that, so what do we do to get rid of this? Well, remember, we can't change the weight of this. We have to keep it balanced. So anything we multiply by has to be the same on the top and the bottom. And the simple rule for this is identify the radical in the denominator and once we do that, multiply by that radical on the numerator and denominator. So a common mistake would be to do just one. We have to do this root 4 on both the top and the bottom. So when we do this, we're going to have 7 root 4 on top and then just 4 on the bottom. A second thing to note, exponent rules, radical rules, sorry. If you multiply a root by itself, it simplifies to the radicand, or the number inside the root. So this only works for square roots, or I should say, yeah, square roots. So if you have something like root 2 times the root 2, it simplifies to just the number inside. This is true for all roots. So if you have the root 7 times the root 7, still just equals 7. By definition, we are squaring a square root, so the squares basically cancel each other out, and you're just left with a number. Now the tricky part here is, what if we had something like 4 times the root 6? In this case, we actually don't need to multiply by 4 to get rid of the root. We just multiply by, you guessed it, only the root. When we do this, we'll be left with the 4 is still there, and the radicand, or the number inside of the root. So final answer there would be 24. So a few examples of this, and the reason why we're spending a few minutes here is because it's really important, and if you don't know how to do this skill, you can't actually get into the trigonometry or the algebra 2 part of this lesson. So if we take something like 2 over 5 root 11, to rationalize this, identify the square root, follow step 2, we multiply by the root itself on both the top and the bottom. So here we'll have 2 root 11 over 5 times 11. When we simplify this out, we'll get 55. And that is our rationalized answer. So again, we are identifying what the root is. Once we do that, we multiply by it on both the top and the bottom. So that's going to make the rest of our life quite easier. And once we do that, we'll be in good shape. So a few things to remember from the other day with our special right triangles. And I'll write out just sine, cosine, and tangent. If you're missing the other ones, it's on you to go back in your notes, because we've had 2 days of these now. You can always redraw the triangles if you're not sure, but just a quick recap. of what these values should be in your notes currently. So that'll be good enough to get us started here with some of the following operations. So the key of what we're going to be doing next, 1 or 2 practice problems, we'll do 2, is again using those rationalizing the denominator type situations to get ourselves in a position where we can simplify these things. So let's try something here. What if we have, let's say, the sine squared of 30 plus root 7 times the cosine of 45 minus the tangent of 60. So what do we do here? Just go one step at a time. So here the sine of 30 is 1/2. So we take that and we square it. Next, the cosine of 45 is root 2 over 2. And then finally, the tangent of 60 is the square root of 3. So we go through one step at a time. And we simplify anything that we can. So at this point, we really can't get too much more simple than this. We could make some common denominators here. But a few things to note. When we have a root on the outside, this is an invisible 1 on the bottom, so we multiply the tops. If we multiply square roots, we multiply what's inside, and then keep that number under the root. So here, 7 times 2 gets us the 14 that we see inside of this root. So another thing to kind of take note of there. All right, let's keep going. So what if we add something like the tangent of 45 times root 5 times the sine of 45 times root 10 times the cosine of 60. If you're like, Mr. R, this is a lot of stuff. That's the point. We're taking this to the next step. It's going to be a little bit harder to do these, but again, the key is we are just taking values that we know, and we are replacing them with their values in the table. And here, let's make this even more clear. 3 different colors, 3 different values. Cosine of 60 is here. The sine of 45 is here. And the tangent of 45 is here. So just rewriting this with everything that we have. Once we do this, we can make all of these fractions by putting 1s underneath it where they don't have them, and just multiply straight across. So on the top, we're going to get 5 times 2 times 10, which is 100. And on the bottom, 1 times 1 times 2 times 1 times 2 is just basically just 2 times 2, which is 4. So we'll get 10 over 4. We can simplify this down to 5/2, or 2.5. So that's the point of today's video, is using operations with those square roots, using the values we know